Welcome to the lesson BIPV as a viable option in building renovation package. The course is introducing BIPV topic, that is building integrated photovoltaics. I'd like to start with a short overview on the history of BIPV development over the past 10 years. At international level, several projects dealt with this topic, thus a lot of developments were carried out. Our institute at EURAC Research has been working in several projects in the past 10 years focusing on this topic. At the beginning of the past decade, a lot of research focus was on technology development, such as new PV modules, new integration substructures, new components and new systems. Another aspect that was very much brought into attention was aesthetics, because it was clear that public acceptance of BIPV was a key factor to succeed in market penetration of this technology. Of course, if people have a negative perception of this technology and they think that PV modules are ugly, they wouldn't like to see them placed on their buildings, on the facades, on the roofs, or in their cities. So, in those years, several projects were addressing this challenge. For example, we were involved in an FP7 project named Solar Design to develop new technologies, in particular flexible photovoltaic modules to address architect needs. Another project was the International Energy Agency Task 41 on solar energy and architecture, developing dissemination of best practice to show how PV can be integrated with high architecture value in the built environment. So it was highlighted that architects are very important stakeholders of the BIPV value chain who must be involved in order to succeed in boosting penetration of PV in buildings. So in these projects, the focus was very much on architectural integration level. In most recent years, another aspect of integration arose, that is the energy integration, meaning the ability of PV to be integrated not only into the envelope of the building, but also to be efficiently integrated in the overall energy system of the building. So that means the ability of PV to interact with the building loads, to maximize self-consumption and producing energy in the time when you actually need it. And on the other side, to efficiently use the energy that is produced on site within one or more buildings. So the concept is maximizing the energy used on site and minimizing the energy fed into the grid. This is what I mean by energy integration. So EURAC is currently coordinating a research project named Energy Matching that, as the title suggests, is addressing energy integration and in particular the matching between renewable energy on-site production and building and district consumption. So what we can conclude after this brief overview is that when we talk about integration of PV, it is essential to consider three aspects of integration. So the technology integration, the aesthetic integration, and the energy integration. So all these aspects are important to succeed in BIPV design. Taking advantage of our experience gathered in the past 10 years on BIPV topics, thanks to several projects we were working on, we developed several tools to support architects and engineers in the implementation of BIPV. I'd like to mention in particular EURAC website on BIPV, where we collect all tools and information that we believe are useful for architects and engineers to approach BIPV design. There you can find a platform collecting BIPV case studies. So if you like an example, for example, you can download a PDF where you can find a lot of information on products used for that BIPV system, such as PV modules, energy system, pictures and drawings on technology details and so on. There is also a section describing a software tool that we are developing to support early stage BIPV design. The tool will be available to the public in around 1 year through the energy matching platform. The tool is based on some algorithms that can optimize several parameters such as energy matching, so the matching between electricity production and consumption, but also economic aspects. The tool can support you in defining the best BIPV configuration for your building or group of buildings, providing both the optimal sizing and position of PV within your building envelope. I'd like to conclude with an outlook regarding the implementation of BIPV in the next years. So while in the past years we were used to conceive the energy production as something that was relegated somewhere far from us in a centralized power plant, now we move towards a decentralized energy production where buildings are not conceived anymore as energy consumers, but also as a potential producers that are able to harvest solar energy through their skin. So they are becoming the so-called energy prosumers. This is opening new challenges related to energy sharing and how to optimize the local use of renewable energies within multi-residential buildings and also among several buildings. European policy is pushing toward the direction of energy sharing, energy communities, but there are still some technical and above all non-technical barriers that still need to be removed in order to speed up the process, such as regulatory framework and normative aspects at country level. Anyway, this is becoming reality in all over Europe, and for sure BIPV, as the main technology able to produce electricity from renewable energy within a building, is playing and will play a crucial role toward these energy communities.